Assalamualaikum warahmatullahi wabarakatuh. The presenter today is my name is Nafis Syahmi Zainal Azali from Universiti Teknikal Malaysia Melaka. Title for this research for second international conference on applied thermo-fluid and computational fluid mechanics 2020. Thermal properties of wood dust fiber and recycled polypropylene for development of thermoplastic composite filament of fused deposition modeling FDM. For FLIGHT for this project is TS Dr. Nuzaimah binti Mustafa, Dr. Ridwan bin Jumaidin, Dr. Muhammad Razi bin Ali. Introduction. For introduction content of three parts, which is the first one is nature fiber, biocomposite, or waste of wood dust. The nature fiber are biodegradable and may be produced in large quantities without displacing other scopes. Then become vital of contemporary life to use wood that are more environmentally friendly, cost-effective, and healthy than others. Wood dust fiber is made up microscopic particle found in furniture, pulp, paper, and others industry, which is wood dust is to have a lot of waste. Then using biocomposite made from the waste polymer and natural fibers such as recovery polypropylene (PP) and wood dust fiber for 3D printing in terms of thermal expansion and contaction of wood dust fiber. Problem statement for this research, which is have two parts. The first one is wood dust is basically residue of small particle found in the industry, furniture industry, pulp, paper industry can cause of pie shape and mostly burns resulting in environmental pollution. The second is most of the data available today is using standard material, which has been studied for 3D printing. So for this composite material, there is no complete specification of data to use on an extrusion machine, which is the commercial or the standard data for 3D printing use of ABS and PLA. So for this project or this research regarding wood dust and polypropylene, which is no data. Aim of this research is to develop thermoplastic composite, the thermal characteristics of wood dust fiber and recycled polypropylene. Scope for this project only, study of thermal properties of wood dust fiber and recycled polypropylene after treated the fiber only with now natrium oxide, which is the alkaline treatment. The second one is perform the chemical treatment, which is using sealant as a coupling agent. The literature review or for review from the previous, which is the content of two. The first one is alkaline treatment, and the second one is chemical sealant. For part of alkaline treatment, which is using of natrium oxide solution as a washing agent to remove dissolved metal. According to Kumar et al. 2018, using of 6 or 5 fiber loading, which is 2.5, 5, 7.5, 10, and 12.5, which is using 2% weightage of course now, then stay for 8 hours, then dry for 60 Celsius. The second is the according to Sun et al., which is the same use of now or KOH solution for 24 hours without stirring. After that, wash several times with distilled water, then dry in oven at 45 Celsius. For chemical treatment or sealant, using or sealant solution as a coupling agent act as the sort of intermediate which bond of organic. According to Anon 2017, then his use of 2% of sealant and combination of 6% of now sealant for 3 hours. After that, for according to Aida et al. 2021, using of the same two sealant, in concentration of 0.75%, which is immersed pH of solution was regulate 3.5 until the 4.5. After that, methodology for this research, which is the starting for sample preparation content of wood dust, polypropylene now, and sealant. Wood dust from the filler size of 125 millimicron only. After that, preparation total of around 2 kilo of wood dust getting from the furniture workshop at the Aloe Gajah. Then wood dust is must wash with distilled water and dry at the 60 Celsius for 24 hours. For polypropylene, use of recycled PP, which is the shape of the PP is recycled PP is 3 mm. Then preparation of recycled PP around the 2 kilogram. Then for now solution, which is time to immerse 2 hours and without stir. After that, the preparation of now about the percent of concentration filler wash distilled plus of the percent of mixture. Example, using of 100 gram wood dust, which is the 10% wood dust. After that, the mixture of now and the distilled water around 90%. Then after that, dry for 24 hours at 65 Celsius in oven. Then for sealant, it's time to immerse 3 hours. Then the calculation is the 2% of volume of sealant plus 90% of methanol, distilled water. Before that, maintain of the solution around the pH 3.5 until the 4.5. The same to the dry for 70 hours at oven 60 Celsius temperature. And this is the flow of the preparation wood dust fiber getting from the furniture workshop before sieve. After that, using of sieve, if wood dust getting 125 millimicron. Then getting the raw wood dust after sieve without any of residue or rubbish. Then the preparation like polypropylene or PP, recycled PP, sorry, like this form. Then after that, for getting from raw wood dust is separate for to now alkaline treatment of now and chemical now, like the already informed the percent of using solution the same to alkaline and chemical treatment. After that, dry inside oven for 3 days for sealant and same to now. Then for thermal test characterization is the TGA, thermogravimetric analysis using of temperature 0 until 800 Celsius. A heating rate is 20 Celsius per minute. The sample test are recycled PP, now treatment and sealant treatment. After that, for DSC, differential scanning calorimetry, using of the same tool, using of 30 Celsius until the 800 Celsius. Then heating rate is the same to TGA, 20 Celsius per minute. Then the sample using is the recycled PP only. Then result regarding of TGA. This is the graph for result TGA, content of weight against of temperature. The first one is recycled polypropylene. The second is now treated, and the third one is the sealant treated. After that, for this graph is the TGA, the thermoplastic quantities of material which enable to recycle and use. Thermal degradation is necessary to detect degradation of fiber at a certain temperature. This method may be offered information on a material capacity to endosity, high temperature is performed correctly. Then for flow of result of or the discussion for this TGA, the first there was the first from the 100% is a first degradation phase during which is moisture content began to evaporate. After that, The second phase, during which is high temperature is applied to remove chemical content, such as hemicellulose, cellulose, perfect, and lignin. If finally is final stage, the final residual less than 10% weight is the desegregation of wood dust fiber. Temperature range from 10 to the 300 Celsius. After that, the fiber to begin the lost moisture at this or this evaporate during this phase. Weight loss at this stage is presently less than 9 Celsius of the total weight. Then the chemical composition of the fiber or the such as cellulose, hemicellulose, pectin, and lignin is progressively destroyed at temperature 300 to 500 Celsius. Then hemicellulose is the first functional group of to break down, followed by cellulose, lignin, and cellulose being more stable than the hemicellulose. Then for DSC, content of the first peak which is the known exothermic temperature at 170 Celsius correspond to melting temperature of recycled polypro-Lene. The second peak point, which is unknown exothermic, occurred at temperature 472 Celsius, which is correspond to the greatest temperature can be reached by regenerate polypro-Lene before it's burned. Then the graph is to explain about the extrusion operation was successful if extrusion temperature is set between 197 and 472. The assay results are used of the marker for maximum peak temperature, but they are also dependent on the condition of setup machine mechanism. In addition, other factor and machine configuration. Furthermore, if the DSC test is result or confirmed, it's hoped that the temperature of using 160 Celsius until 180 Celsius may be developed to achieve certain composite filament, which is to get the perfect composite filament and yeah, complete during extrusion process. Then conclusion. The conclusion, which is the wood dust fiber have a high potential for usage of FDM filament synthesis. This synthesize filament from the wood dust particle. The importance of heat testing wood dust fiber of FDM users cannot be overstated. This WPC is must be filament pin test specimen before being examined for porosity, size test, and mechanical strength. Finally, the thermal characteristic for all form of fiber loading must be investigated to decide which is preferred to get the filament. This is also for untreated fiber loading, where the outcome for or extending filament for mixed fiber and matrix to perfect composite filament. With a strong fiber matrix link expected to be created based on the finding of this data investigation. That's all for today. And for really express for this project, which is since I graduated to Teknikal Malaysia, I have a grant of Minister KPT for financial for provide the research grant like PJP, FTKMP, PP, according to Honor Dr. Nuzul Mustafa. Then the consource of support is regarding to Dr. Ridwan Jumaidin. Thank you. That's all.